Okay, let's talk about the displacement node. Before we dive in too far, I want to point out that there is another section on the Redshift object tag and the options for displacement that you'll need for this displacement node to work. So if you haven't seen that yet, go ahead and check that one out after this. So assuming that you've got your geometry set up and the tags are right, in order to make your displacement work, you're going to need the Redshift displacement node and something to drive the displacement. In this case, I have an image texture, but you could also use more procedural solutions like noise, for example. All right, so let's quickly just take a look at what our map looks like. So we got an idea of what's going on here. And at the same time, let's talk about this map encoding dropdown. So we have two options. There's height field and vector. We'll talk about vector in just a second, but height field is going to be the most common displacement type that you're going to find. It'll look like a black and white image, and essentially that means one of two things: either black equals 0 or no displacement, and white equals an arbitrary value of 1, which we will assign a scale to. But the white elements will essentially just poke out of the geometry and displace the surface. So with a fairly low resolution mesh, at render time, we're actually able to get this lovely extra detail. So scale works in tandem with the displacement scale. Both of these numbers are referencing how much displacement there is. If I flip it down to 0, you're going to see our surface flattens completely out. If I dial it up to 1, we're going to have this scale multiplier multiplied against the displacement scale multiplier. Now, the second type of map you might get is that you'll see a lot of gray on it with a little bit of white and a little bit of black. And that simply means that gray is actually the original surface and white is extruded outward or displaced outward, and black is displaced inward. And if that's the case, we can use this handy dandy change range and just say our new minimum is going to be -1, and that means any of the dark values below 50% gray are going to extrude inward, and any of the white values above 50% gray are going to extrude outward. So if I lower my scale down to 0.5, we're going to see the darker areas rise up and the lighter areas collapse down, just like that. Now, there is another type of displacement, and that is vector displacement, and it's actually really, really a lot of fun. So let's take a look at that one real quick. Flip my light on. So with vector displacement, you're gonna have this really interesting looking weirdo color displacement, and effectively what it's doing is not only displacing outward from the surface, but it's also taking X and Z into account and gives you this really cool, almost, I guess, like a volume displacement where it has the ability to curve back around underneath itself. And if it's totally confusing what's going on here, let me go ahead and drop down a wireframe node, and we'll just kind of step through what's going on. So if I lower my subdivision amount down a bit, maybe up a little more, there we go. And I'm also going to turn off screen space adaptive. There we go. Now we can really see what's going on here. You can see as I begin to walk this displacement down, you'll notice that really the way that this is working is it's stretching out a lot of these polygons in order to give it that extra volume. So if I were to just go walk this up, you'll see they start kind of stretching out, which is important to note because often vector displacement will require more subdivisions than a height field displacement. As we can see, we have like these really tiny little guys over here, but also like these giant big ones that have been stretched out. And if I turn off tessellation just for a second, maybe walk this down, you'll see that we kind of actually need those higher subdivisions in order to get all of the vector displacement detail. Flip that back on, walk my scale up to 100. And yeah, so even as we're subdivided pretty well out here on this flat surface, you can see like right here, this inward displacement's getting really, really stretched out. So we just have to keep cranking until we have enough subdivisions that all of those giant stretched polygons get smoothed out.